Okay, cool. So the next question that we got on the menu today is asking us, what are some examples of electromagnetic waves? So electromagnetic waves, they are caused by electricity and magnetism. Electricity and magnetism. The reason that they exist is electric waves or electric fields will incite magnetic fields, and magnetic fields incite electric fields. So these fields create each other, and they like chain create each other in like a transverse wave. So they electric fields induce magnetic fields, and vice versa. So let's say if we have red for electric red, and we have magnetic blue, like we're gonna have this and this, we're gonna have this and this, which will incite a this. Like I'll just draw these out to like kind of make it like more clear. But like these waves are kind of like this. Kind of what's going on here is, imagine that we have like a line going through here. This would be like a diagonal view. But we know that like vertically, this would be like the red. And horizontally, it would be the blue. Magnetic. Red, electric. So the fields that they induce on each other are perpendicular to each other. It's kind of tough to see from the diagram. And maybe if we have like a vertical line, like that, but like, you know, just know like the blue is supposed to be horizontal and the red is supposed to be vertical. It's just kind of tough to draw three-dimensional things on a two-dimensional page. But these are kind of what electromagnetic waves are, and they can exist at different frequencies, and at different frequencies they will have different properties. So frequency or wavelength, because they are pretty much the same, they're different ways of saying the same thing. It's like how wavy is the wave, I guess is the best way for me to describe that. Frequency or wavelength of electromagnetic wave determines its properties. Okay, so here, very conveniently, we have a little spectrum of a diagram of different types of magnetic waves and how we can interact with them. So at low frequencies, big wavelength, because they are inversely proportional to each other. So we can write that as frequency is proportional to 1 over wavelength. Okay, they're proportional to each other in an inverse sense. So at smaller frequencies, larger wavelengths will have like radio waves, and these waves are quite long. So if you ever seen like a radio tower, they're transmitting radio waves. That's electromagnetic radiation, electromagnetic waves, at fairly low frequencies, fairly long wavelengths. These could be like a couple of meters. So like, you know, if you spread out your arms, that could be like a wavelength for a radio wave. These are used to like transmit information. So if I have a receiver that interprets those radio waves, you can embed some information inside of the wave to maybe send me a message. Radios do this by sending, like, they encode audio information inside of those waves. So they can do it with amplitude modulation. That's with AM radio versus FM, where they're doing frequency modulation. And how they change the frequency or the amplitude that's how they encode in the information of the sound that you'll typically have when you listen to the radio. That's it's cool stuff. Next thing is microwaves. Microwaves, well, where have we heard microwaves before? Well, I have one in my kitchen that I use to heat up my food when I'm hungry. And the thing about microwaves is that they work because the waves that they produce are at a similar resonant frequency to the resonant frequency of water. So the radio waves, the electromagnetic waves that your microwave makes, will wiggle the water, or they're going to pierce through your food, but all the water molecules inside of your food are going to start vibrating at that same frequency, because that's the same as the water molecules' resonant frequency. And because of that, the water molecules are going to increase their kinetic energy, because they're like I mean, the water molecules, to kind of put this in a kind of a metaphor, the water molecules are like, yo, that's my jam, that's my frequency, and they're jamming out. They're like bopping their head to the frequency of the microwave, and as particles increase their kinetic energy and they're wiggling a lot, the temperature increases. So that's why when you put your food in the microwave, it will heat up. But if there's no water in there, there will be nothing to heat up, because it really just goes off the principle of water. Now, the next thing that we got here is infrared waves. That's another type of electromagnetic waves, but the frequency is getting higher, and it's also getting shorter in wavelength. So the waves are more bouncy now, more bounces per a couple seconds of interpreting the wave. Infrared waves are quite interesting because they have a lot of applications. One application is in night vision goggles. So when you're in the dark, you can't see stuff because there's no visible light, but there is infrared light that's always there, because basically, like, everything still has heat, and heat makes off a lot of infrared radiation. It's kind of like light that's not necessarily visible to our human eyes, but if we have night vision goggles, some animals might be able to see infrared light as well, but night vision goggles, they pick up infrared wave information, and then they transform their infrared information into visible light information, which allows you to see in the dark without like flashlight. It just interprets the infrared lights and transforms that into visible waves. And another thing that we use infrared for is for remote controls. So if you ever taken a video of the front of your TV controller as you push some buttons on it, you can see like there are some lights that are going to be outside of your TV remote, outside of its like light emitter. Those are infrared waves. Some cameras can pick them up, even though the human eye can't. And they're like that because TV remotes are pretty much just laser pointers, but they point infrared light that I guess the receiver, maybe your TV, is going to interpret, and then they'll be like, okay, you just sent me a signal. That signal said, turn myself on. So TV says, okay, I'm turned on, and let's watch a movie or something like that. So that'd be an example of infrared waves. Next thing is visible light. That's all the light that you can see. It's actually a very small segment of the electromagnetic wave spectrum is visible light. This would be just the light that you see, all of your favorite colors, and like the rainbow, red, green, Roy G. Biv. Like here we have a low frequency, and here we're going to have high frequency. So if you increase your frequency, you're kind of moving more towards the purple side of the rainbow. Yeah, and all colors are just parts of the visible light spectrum, which is a part of the electromagnetic wave spectrum. Okay, cool. So the next thing that we got here is ultraviolet light. And ultraviolet light is light that is a higher frequency than purple or violet, and humans can no longer see it. The sun has a lot of UV radiation, and these waves are much more bouncy. And when you tan, it's really like the UV radiation from the sun that is like impacting the cells in your body, and that's what like causes tanning. And if you have too much, well, it's going to be uncomfortable for you. The next level up in terms of the electromagnetic wave spectrum, we have X-rays. And X-rays, well, if you've ever been to a hospital, I've got an X-ray before when I broke my spine, but it's fun times. X-rays are even higher frequency waves, and they have like much higher energy, and they're used to see through things because the energy in the wave can like pierce through stuff. And even higher level is gamma rays, and these are kind of used for like more like science, but scientific research reasons and that type of stuff. But the higher frequency the stuff is, like these waves have a lot of energy, because the more that you have higher frequencies, the more energy that wave is going to have for it to exist. And these higher frequencies waves, electromagnetic waves, they can do some damage to your body. So that's why typically you don't want to spend too much time around X-rays, because it's not great for you. Also kind of why ultraviolet light, because that comes from the sun. If you're tanning too much, it could lead to some problems with your skin. So yeah, the higher frequency, the more possibility that it can harm you, because the energy will cause the cells in your body to have more energy than they expect, which could lead to some unexpected behavior. And if your cells are not happy, well, you are what you are. You're just made of cells, and if your cells are not happy, well, you could be having a bad time. So yeah, the above solution solution is good. Could be enhanced with some real world applications of electromagnetic waves. Cool.